Hello everyone, I'm Rituja Jori, Venture Services Manager at Altitude Accelerator, and today we are here with Aaron Guan, CEO of Neptune Nanotechnologies. Hi Aaron,
Hi everyone, how are you?
we are doing great. Are you excited about the conference?
I'm very excited. Collision always brings huge energy to Toronto, and that's our second time here this year, and we're here every year. Huge energy. We enjoy the event very much.
Agreed. Let me do a quick introduction of Aaron for our audience. Aaron is recognized as one of the most innovative young serial entrepreneurs and one of the most influential people under 35 in plastics industry. He has been featured in Forbes 30 under 30. He is also a board of directors and newsletter chair for the Society of Plastic Engineers, Thermoplastic Materials and Foams Division. Aaron founded Neptune Nanotechnologies in 2022, which specializes in development of novel nanomaterial known as chitin nanocrystal, a fishing waste source single crystal with a wide range of applications. Can you explain what chitin nanocrystals are and how they are sourced from organic fishing waste?
In terms of kite nanocrystal, what we do specifically is we're turning the shells of crab, shrimp, and lobster, and we're converting them into a nanomaterial. It's called kite nanocrystal. It has identical chemical makeup as what makes these shells, but it is turned into a nanoscopic material. And by way of doing that, we made it significantly stronger. A nanocrystal is stronger than steel, lighter than plastic, and of course, being from fish waste derived, it's also fully sustainable.
Wow, that's really fascinating. What makes these crystals stronger than steel and lighter than plastic? And how do these properties translate into practical applications?
This is the beauty of nanotechnology. A nanometer is what a nanomaterial is defined as a material that's engineered on a nanometer scale. It's very, very close to atomically sized. And imagine if we can arrange all the atoms and the molecule chains in an internally flawless, perfect way. Once you remove all the defects, the material becomes incredibly strong. And this is what a single crystal is. It's an internally flawless crystal. And in terms of a practical application, we're all Canadians. We love our morning coffee. And here we have a very standard paper coffee tray, right? So the challenge with paper packaging in general is that it is relatively weak in performance. And once you get it wet, it becomes soggy, right? The soggy paper straw problem. And the third issue is paper is flammable. So with our nanomaterial, just 1% of our nanocrystal, we can solve all three of that problem. For example, we have this piece, it's almost like a brick of a material. And these two are identical, except that this contains 1% of our nanomaterial. Significantly stronger, stiffer, water resistant, and this won't burn actually.
That's a great product, Aaron. Neptune's nanocrystals have applications from aerospace to biomedical devices. Can you discuss some of the most exciting uses and the impact they have on their respective industries?
We're very, very excited about the packaging space that we spoke about because we're solving the strength problem. We solve this paper works great as a plastic reduction and as a plastic alternative, but it is challenging to use because of those problems I mentioned, lack of strength, lack of water resistance. We're solving that, and that brings a huge step forward for sustainability. There's also weight reduction opportunity as well. So we're really excited about the implications in the packaging space. But of course, on the more advanced side, our nanocrystals can be added to advanced composite materials like the ones you mentioned, for example, aerospace, wind power. These are composite materials that we're also making them a lot stronger, a lot lighter, and we're eliminating the chemical additives that's used in these industries. So, both from a VOC emission perspective and both from a light weighting, weight reduction perspective, we are trying to improve the sustainability aspects of these.
Amazing. So, how do Neptune Nanotechnologies contribute to sustainability? What role bio-based, non-toxic, and biodegradable materials play in future of material science? And I think this would be your favorite topic.
It definitely is my favorite topic, and it's all about the circularity of our story. A fish waste derived source can solve so many problems down the line. So from a supply perspective, for as long as we keep eating seafood, there's going to be plenty of supply. We have a endlessly renewable source, and we're repurposing that waste stream into advanced technology that in turn solves problems in plastics, in packaging, in composite materials. And we're attributing a few of those properties. First of all, it's the property of these material being fully natural, non-toxic, and it replaces chemical additives. Secondly, it creates weight reduction opportunities, and that is a life cycle problem. And we're basically reducing a life cycle of CO2 emissions from all the packaging that's being shipped all over the world. And really, the third aspect is really the safety of the material, the biocompatibility, the biodegradability. And we're basically bringing full circles from cradle to grave, right, from source to end of life. We try to create that entire sustainability cycle. That's what we're doing.
Thanks for sharing those insights. It seems like you are onto something really great. And thanks for joining us today. It was nice having you at our interview session.
Thank you so much for the opportunity to showcase us. We really appreciate this.